Okay, so this lesson is going to give you some help on page 223, questions 85 in that area. The directions are to approximate a zero of a polynomial function using the intermediate value theorem. So I'm going to show you how to do that. Basically, an example of a polynomial function that you might get is f of x equals x cubed minus x squared plus 1. You can type that into your graphing calculator and take a look at the graph. And when you do, you'll see that the graph crosses the x-axis only once. Now, something interesting is if you have a degree 3 on a polynomial equation, you could have 3 roots. So it could cross the x-axis 3 times. This particular one crosses the x-axis once. Now, I have another polynomial equation over here, and this one crosses the axis. Oops, let's see if we can get that a little more in view. This one crosses the x-axis 3 times. And you can look at your graph, type that in, and look at your graph, and you can see that it crosses the x-axis 3 times. So what we're doing when we're approximating the zero of a polynomial function, we want to know exactly where does it cross the x-axis. So let's deal with this equation first. If I type this equation in, and I look at my chart, look at the chart of values on my calculator, I see, look at the table, and if you look at the table, you can see a whole bunch of values. You can use your up and down arrows to get a whole bunch of values. But what we want to do is sort of narrow down on where it does cross the x-axis. If you look at the curve by looking at the graph on your calculator, you can see that it crosses the x-axis somewhere between 0 and 1. But exactly where, we're not sure of. You know, in the picture you can see it a little bit. You can also see that it crosses the y-axis at 1 and then continues up this way and continues down this way. So what we're going to try to do with this is narrow down and find out exactly where does it cross the x-axis. Looking at this chart, you can see where it crosses the x-axis by watching where there's a sign change under the f of x column. And here I have minus, and if I look up, those are all minuses. I go down, I finally see between minus 1 and 1 is where it changes on the x-axis. So we're going to try to zoom in on what happens there exactly. So I like to make a new chart for that. So, and at the very top of my chart, I'm going to put minus 1, which is a value. And down at the very bottom, I'm going to put 0, 1. That's where I'm going to sort of narrow in. What happens between those 2 points? Well, between 0 and 1, I could find exactly halfway between there. That would be negative 0.5. So I wonder what the value is at negative 0.5. I just put a curve in here. I don't know how exactly right that is or not. So let's just see. So I'm going to use my calculator, and I'm going to go to table set, which is the second button and the window key. Table set, and I'm going to set it at negative 0.05. So negative 0.5. Not 0.05, 0.5. Then I'm going to look at the table. So that's the yellow button and the graph button, second table. And at negative 0.5, it's 0.625. So 0.625. So where is it really? At halfway, if this is 1, half of that is 0.5. So 0.6 is about right there. All right? So it's not close enough to cross the graph there. So now I want to narrow in some more. Do you think I should go between negative 0.5 and 0 or negative 0.5 and 1? I hope you chose negative 0.5 and 1, because it looks like it's going to get closer to the graph there. So let's try halfway between these two. How about negative 0.75? And let's find a value for that. So again, I go to second table set, which is the second window button, and I'm going to type in negative 0.75. Hit enter, and let's go to the table, second table, And at negative 0.75, I have 0.015. 0.015. So, at negative 0.75, which is about 3/4, I'm at 0.015. So I'm just a little bit above the axis. So that is close enough. It rounds to 0. It's approximately 0. So I could really make a guess that this crosses the axis at negative 0.75. And that's really how to zoom in on a graph. Now let's go back and look at the other one that we wanted to talk about. Let's get rid of this stuff. All right, if I make a chart for that one, here's a chart. I just type it in, go to second table, look at the table, and get the chart. And now I want to find the zeros of that using the intermediate value theorem again. So, when I look at this chart, remember I said to look for sign changes. Well, there's one. Now I got positives. Uh-oh, positive to negative. There's another one. Uh-oh, negative to positive. There's another one. There's 3 sign changes. So that means that this picture must cross the axis in 3 places. At negative 1, negative 1. Let's plot that point. So negative 1, negative 1. That's this point here. At negative 2, I'm way down to negative 17. So let's just draw the line down there somewhere. At negative 1, did that one. At 0, I'm up to 3. Okay. So you see, if I connect these 2 points, I could just draw a straight line there. Not an accurate connection, all right? We're going to zoom in and find out where exactly does this cross the line. You know, if you think of a couple potential places, it could cross it straight in the middle. It could cross it closer to the negative 1. It could cross closer to the 0. And I want to know exactly where. All right, let's plot some other points. Over 1, up 1. Over 2, down 1. All right, so here I cross again here. So I could sketch in from 0 to 1. I could sketch this because I know it doesn't cross the axis between these two. But here again, I don't know, does it cross in the middle? Does it cross closer to the 2 or closer to the 1? I don't know. All right, let's look at 3. At the point 3, oh boy, I'm up to 3. So at 3, I'm up here to 3 again. So I know that it crosses, if it's at 3 up on 3 and at 2 it was down at negative 1, I know that I crossed the axis sometime between here. And I don't know, does it cross right in the middle? Or does it cross closer to the 3 or closer to the 2? So we have 3 places to narrow in on or to zoom in on and see what is the activity of the curve there. We're going to zoom in on, let's do between 1 and 2. It crosses between 1 and 2. So I take and I make a new chart, x, f of x. For 1, at 1 I'm at 1, and at 2 I'm at negative 1. And now I have some space to try and figure out what happens between 1 and 2. Well, first thing I like to do is the exact halfway point. So 1.5. What happens at 1.5? So again, you can go to your graphing calculator here, and we're going to type in, let me get it on the right graph here, second table set. So I want to see what happens at 1.5. So I'm going to do table set 1.5. Then I'm going to go to second table, and 1.5 gives me the value negative 0.37. Negative 0.37. So at 1, I'm up at 1. At 1.5, which is halfway, I'm down here, negative 3.7. So at 1.5, I'm down at negative 0.37. So that's less than halfway, so it's right about there. So I could connect from here to here, but I'm not sure exactly where it crosses the line. So let's try 1.4. That rounds to 0, but I want to narrow it down a little bit more. So now I'm going to go to second table set, and I'm going to type in 1.4. Then I'm going to go to second table, and at 1.4 I'm negative 0.136. Negative 0.136. That is very close to 0. So at 1.4, which is a little bit less than half, that's where I'm going to let it cross the axis, right there. So I narrowed in, and that's a pretty close answer. Both of those could be, if this answer rounds to 0, you can call it a good estimate. So 1.4, 1.5 would be an answer that gives you 0 for this function. Now I could try to narrow in between negative 1 and 3 if I wanted to do that. I'd put another chart here. I'd put at the top the 1, 1, and no, I'd put 2, negative 1, and then at the bottom I'd put 3, 3. And again, I'd zero in. I'd do halfway first, and then continue that. So that's how you approximate a 0 using the intermediate value theorem. So good luck with your homework.